So in order to demonstrate how useful VDBs can be when modeling or when setting up a scene procedurally, I downloaded this 3D scan of an antique statue from 3dscans.com and just dropped down a transform node to take care of putting it into the center point of my scene. And what I want to do here is, on the one hand, build a network of interconnecting lines, then use the VDB tools to make them appear a bit more organic. So let's get started and first create a VDB from polygons and create a fog VDB. So we can scatter points into this 3D scan. Wire this up, highlight it, and we see we now created a fog volume. So let's drop down a scatter, wire it up, highlight it, and we see we have now points scattered throughout our volume. Now let's quickly drop down a connect adjacent pieces, set that up to connect adjacent points, and maybe decrease the maximum number of search points to say 10 and increase the search radius to say something like 0.3. Wire this up, highlight it, and we get this. Maybe dial down the search radius a bit. By middle clicking in here I get this value ladder, so I can, with the mouse over, just dial down my value really precisely. And what I don't like about this is the regularity of those scattered points, the uniformity of them. So let's go into the scatter sub and down here, disable the relax iterations so they get scattered more erratically. Dial up the search radius again a bit, like so. Now, let's just use a wireframe here to turn those lines into geometry and dial down the wire radius a tiny bit. Maybe a bit further, like so. And now what I'd like to do is drop down another VDB from polygons here, wire this up and highlight it. And now this takes a while because it's a lot of geometry to iterate through, and what I can see here, this looks like a mess. That is because my voxel size is too big for a wire that has only a radius of 0.015. So what I like to do is, the biggest voxel size that I tend to use if I have a small geometry is half of the smallest feature of the geometry. So my wire here, so the smallest value that I'd like to use as a voxel size is 0.0075. Let's put that in here. And again, this is half of my wire width, and I later might even need to decrease the voxel size further to get out an increasing amount of detail out of this. But for now, it should do suffice. So let's drop down a smooth VDB here, a VDB smooth SDF sub, that's what it's called, and wire this up and smooth out the SDF that we just created. And we can see here, the result is this kind of rotten, very organic looking thing. And this is not exactly what I'd like. I would like this to look a bit more like ceramic that's molten together but not rotten away. So first thing I could do is dial down the iterations. But then again, this is a bit too little smoothing for me. So let's try another smoothing operator instead. For example, we could try the Gaussian, which is a bit more center weighted, but in this case just blurs out the whole thing. We could try a median value, which also is not the result that we want. And we can try the mean curvature or Laplacian flow, which smooths along surface features of our SDF. Not much difference here, so I'll go with the mean curvature flow and maybe dial up the iterations. That was a bit too much. Yep, maybe like so. I mean, we can already see there's only one voxel here that's already breaking up. But let's give it a try and drop down a VDB convert node. And we want to convert this VDB to polygons. So wire this up and highlight it and see what we get. And we can see this worked pretty nicely, except for some minor issues here. But in general, I mean, for a close-up it wouldn't hold up, but for an overview of the whole geometry, this would be okay. What I could do is decrease the voxel size and thus increase the volume resolution, so I'd get more voxels in those really thin areas here. Or I could drop down a smooth sub now to smooth out the resulting mesh. And let's try that, because the smooth sub in Houdini 16 has been reworked, so it runs nice and smooth, haha, like so. Now let's just have a look at those areas here by decreasing the filter quality and maybe increasing the strength. That was maybe a bit too much. Let's try a curvature dominant smooth here, or maybe a scale dominant. This is just a matter of trial and error to some point for me. So in this case, the uniform smooth seems to work best. And if I dial down the filter quality, this really yields those thin connections that I'd like for this. So let's just quickly assign a shader by going to the material palette and selecting maybe a white porcelain for now. Drag that over to the matte tab and back into our geo level. We go up one level, select the geo node, go to the render tab, material, and assign a material that we just created. Also by control clicking on the environment light, add an environment light, and just link up an HDRI in the environment map. Also make sure you check the render light geometry, and let's just select an HDRI here. And when you load an HDR and have like numbered files in the folder where you load that HDR from, Houdini has the tendency to automatically do this. And what it tries to do is figure out which files belong to a sequence and load in this sequence, which is absolutely not what we want for a single HDRI. So in order to prevent that, we just have to uncheck show sequences as one entry and then select the proper file. In this case, this one. Now, the final thing that I'd like to do in the output is I'd like to add a mantra node, which will configure mantra, Houdini's render engine, and in here just go to the rendering tab, select the physically based rendering, and under limits just dial up the diffuse limit to 10 as well, which will yield 10 diffuse bounces in reality. Also by control clicking on the camera icon, let's just add a camera to the scene. Save this, go to the render view here, and hit render. And I think this might need a little camera adjustment, so let me just quickly do this. And I can adjust the camera in the viewport by locking the currently selected camera to my viewport. That is by going here, making sure my camera 1 is selected, and then locking it with this lock symbol here so I can move it around now. Also, I think this might need a backdrop, so let's just drop down a grid. And let's just quickly rotate it and move it behind my object so we have a nice clean background. Go to the render view again and hit render again. And while this converges, let's just recap what we did. We took a pretty standard setup, which is just connected lines, and through the help of only 3 VDB subs, we turned it into a rather organic looking piece that would be really hard to model and hard to create in another tool that could not work on voxels. So although the operations we just did are really straightforward in Houdini, this is a technique that is rather hard to do in competing software. So what this technique in general allows you to do is turn a very straight, very geometric looking piece of geometry into something very organic. So I now have this very organic picture, but let's take it a bit further and add some of the original geometry back into it. So let's hit stop here, go back to the scene, let's disable the grid for a moment, and let's disable the grid for a moment, dive into the geometry, and I want to make sure this camera lock is unchecked, so I can navigate freely now without moving the camera around. And what I'd like to do is bring back some of that geometry into my rendering. Maybe have half of the sculpture being in its original state and half of the sculpture substituted by this organic thing that we just created. So let's create another VDB from polygons. From our geometry, let's dial down the voxel size, like so. And to start off, maybe just take a box, scale this up a bit, and let's move it over. Turn this into a VDB as well. Same voxel size, like so. And use a VDB combine to subtract one from the other. So my head goes into the first slot and the box into the second, because I want to subtract the box from the head. And in here, in the VDB combine, I'm going to select SDF difference. Let's highlight that, and I can see I just now did a basic bool to my volume. So let's convert that back into a convert VDB again, wire this up, set it to convert to polygons, highlight it, and there we have our head geometry. Let's merge that with our organic thing by just using the merge node and wire in both geostreams and highlight it. Like so. Not all too impressive, I guess. So let's take this a bit further by, instead of the box here, dropping down a grid, which should be on the XY plane in our case, but like so. We can dial down its size to say something like 4x4. Then scatter points on that grid, like so, and drop down a copy to points, and let's just use this box here, and let's copy this to the points we just created. And as the box is rather big, this is resulting in a huge mess, so let's scale down the box. You can see now we have those tiny little boxes. They're pointing all in the same direction and having all the same size, so let's drop down an attribute. Randomize and randomize. Maybe not the color, but the normal, and have minimum values of -1 and normalize it like so. So my cubes are on the one hand being rotated, on the other hand they are being translated because I offsetted them before I rotate. So it's like a giant lever that I built. So let's put it back to the origin, the cube that is, and have them all sit on the plane, pointing in different directions. Drop down another attribute randomize. Let's just copy this right up in here. And I want to randomize an attribute called p-scale, which is only one-dimensional. It's just a single float and should range from, say, 0.1 to 1, which kind of didn't work because I checked normalize. So let's uncheck that. And there I have it. My p-scale is now randomized. Okay, let's scale up the box a bit, like so, and maybe decrease the scatter point density to total count of, well, let's say 150, increase the box size a bit more, like so, and wire this mess up into our VDB from polygons up here, which should result in all those boxes being turned into a volume, which we then can subtract from our head geometry, which of course is now cutting the thing in half, which when I think about it, I like it. Okay, let's see what happens after we convert all this back to polygons and merge it, and we now get this weirdly looking thing, which I kind of fancy. So let's just save this and select my main camera again, go back up one level, reactivate the grid, and maybe start a test rendering of this. And while this converges, I can already see this might need some additional tweaking, but I hope you get the idea of how powerful the VDB Combine, the VDB Smooth, and the VDB from Polygons tools are. So now it might actually be a good time for you to try out those tools and see what designs you can come up with.